Okay, let's talk about creating sequences of numbers a little more. So there are a couple of interesting things here. When you have a number and then you have the colon and then another number, so 1:10, what does that do? It basically generates a sequence of numbers that go from 1 to 10. Here we go. That's a pretty neat and elegant way to do that. You know, I could even give this a name. I could call it, I don't know, numbers, and I give it 1:10. There we go. And now I have something called numbers, and numbers is a vector that goes from 1 to 10. Brilliant. Well, this is sort of like a shortcut of creating what we call a sequence of numbers. There's a command that does this more in a more elaborate way. It's called seqs for sequence. It has like a starting value and it has like an end value. And then when you use that command like that, you can also specify something else. You can specify something called by, and now I set that to 0.5. So what does that do? Maybe some of you can imagine already what's going to happen. Oof, there you are. You're correct when you thought, okay, now it starts from 2 and it goes all the way up to the number 10 in steps of 0.5. There we go. You can actually look up what else you can do with the sequence command. Let's check it out. So here we have the help file for it, seq. It lives in the base package, sequence generation. What does it say? Generate regular sequences. It's a standard generic with a default method, blah, 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 and so on. So now we have usage. We can do a lot of different things. And this is essentially what I did. I used sequence, and then I used a number, and then I used another number as the end, and then I used by, and I specified by to be 0.5. You see, there's actually, to be more precise, what I should have done is called this sequence to go the long way, from equals 2 equals 10, and by equals 0.5. So that would be now the long way of spelling this out, ignoring the other things that can happen over here. But you see, it does exactly the same thing. And these are, maybe as a little side note, tells you how you could read those usage lines in the help file. So it wants to have an argument called from, but if you don't specify it, it takes whatever it finds in that first position. So R is a bit fuzzy in that regard. Other programming languages wouldn't be as forgiving, but R kind of tells, okay, whatever you have in the first position, I'm going to pretend, I'm going to take that as the from argument that you did not explicitly specify. And whatever I find in the second argument, I take that as the to argument that you might not have specified explicitly. So this is sort of how it works. It can help sometimes to spell these things out, but if you don't see it spelled out, don't worry, it's really just a shortcut of kind of plugging the numbers into the correct positions. The other thing that we see here is from equals 1. So that means by default, if you don't specify anything, it uses 1 as the starting point. And if you don't specify anything, it uses 1 as an endpoint of it. So these are the default things that you can read out of the help file. Okay, sequences. Another funny way to create a sequence, and that's actually one that we will use quite a lot, is using the rep command. The rep, let me bring up the help file to it first. Rep. What it does, it replicates elements of vectors and lists. It's really just a replication of things. So what is going on here? Well, you can already read the usage file to maybe get a feeling for it. Rep, and then it says x and times. And what is x? X is a vector of something, and times is how many times you would want that thing to be replicated. And when I have rep 300, what do you think is going to happen? Well, it gives me a sequence of 100 times the number 3. There you go, 100 times the number 3. And I could also then do something else. For example, I don't know, let's get 20 times the number 4. I save that in R, and now I can look at R, and here we go, and I have 20 times the number 4. And this will become quite handy when we have to generate networks later on in big adjacency matrices. But you don't just, X doesn't have to be just one number. It could also be a vector by itself. And that's what's going on over here. So you see I have the rep command, but then in the first position, instead of having one number, I have like a C 3.3, 2. So what's going on here is essentially on the fly, first of all, it generates a vector with that thing, right? Here we go, it generates that vector. It doesn't give it a name, because I didn't specify a name, but it takes it as an input for this rep command as x equals that thing. And okay, so it takes that and it replicates that 100 times. So let's see what it does. Let's see how it looks. There we go. You see, now I got 100 times, not just a number, but 100 times the sequence 3, 2, 3, 2, 3, 2, 3, 2, 100 times. Okay, so that's rep. There's a couple of other fancy things. Let's see what that does. Okay, with that option here we have each basically goes through whatever it finds in x in the vector and replicates each one of them 100 times before it moves on to the next element in that vector. Let's run that. So you see, now I get 100 times 3 and 100 times 2. That's what this line of code here did. Vary the number of replications. What does that do? Well, it does something else. I don't know. Let's look it up. So these are more fancy ways of generating sequences. Okay, so maybe let me continue just a little bit on calculation with vectors or with numbers. Here I have like the vector a. Do I have a vector a? No, I don't have a vector a. Let's generate this one here. Now we see what is a. A is this vector that line here just generates. Basically, it just replicated the first number once. That's where this one comes from. And the second number it finds here 5 times. So 3 and then 5 times 2. So that's where it comes from. And we have that saved in A, which is a vector. Okay, now we can actually do some calculations with that kind of stuff. It's pretty cool. So we just take that vector, that A, and let's say multiply it by 3. What's going to happen? Well, as it turns out, this is an element-wise operation. So it takes every element that it finds here in that vector and multiplies it by 3. Or I could go and just take all the elements and add 1 to it. Again, it's an element by element calculation. So from 3 turns into 4, 2 turns into 3, and so on. You can also do something else. You can have logical, a Boolean operator again, a bit like something that we did earlier, to check whether A is 3. So now let's see what happens here. Well, now we get basically we get a vector of true and false statements here. So we know this is our A vector. It's 3, 2, 2, 2, 2, 2. So the first value is actually 3, but the other ones are not, right? So R is clever enough. Again, R is a little forgiving here because it notices that whatever is on the right-hand side is not a vector by itself. Yeah, but whatever is on the left-hand side, A is a vector of the length 6. So what it internally actually does, it kind of turns this number 3 into a vector of 6 times the value 6. And then on an element by element basis, it checks whether that overlaps with the vector A. It's the same vector A. And then I get the statement true, yes, or false, no, and so on. And, you know, maybe it already, I don't know, shines already through how this can become useful, because at the end of the day, we sometimes want to know, are people connected with each other? Or we want to know how many times are they connected with each other, and so on.